No, it's just this paper. It says GCF, difference of squares, sum of cubes, that one. No Cray? No. Is Cray is he an FFA thing or something today? Okay. Okay, here we go. So real quick, this shouldn't take long. You should get a chance to do a little work today. So I want to wrap up the last of the three techniques we're going to learn for factoring polynomials. Quick review: we looked at for two-term polynomials, we had our factoring patterns, right? Our binomial patterns: difference of squares, sum of cubes, and difference of cubes. Yesterday we looked at trinomials. How do we deal with three-term polynomials? And we deal with them the same way we deal with regular three-term quadratic trinomials, only instead of packets of x, we might have packets of like x squared or packets of x cubed or something like that, right? And you got some, you probably still need to do some practice on that one. The last one is actually going to be stuff like this, where we're doing four-term polynomials. And the technique we use is grouping. And I want to review one that we've already done in the past, right? Grouping is what we were able to use. Remember when we learned how to factor trinomials, quadratic trinomials, where a was not equal to 1, we used grouping. Okay, let's kind of just quickly review that process. This is a harder one to factor than any of the other ones we're going to do today. Really, they're not difficult, but it's the same technique. So how do we do this? How do we factor this? The alternative to slip and slide was to use grouping. What did we do? Do you remember? It's been a little while. It's a good review. Better remember? Our goal was to split up this middle term, right, into two terms and then factor by grouping. Got an idea? You do. Okay, I'll translate that. You multiply a times c, so we're going to multiply the 15 times the 4, and we get 60, right? So we want to find magic numbers that multiply to 60 and add to negative 23. So what would those numbers be that multiply to 60 and add to negative 23? Yeah, negative 20 and negative 3, right? Okay, so we're going to get, those are our numbers. Okay, so that just means we're going to split that middle term into, it doesn't matter which order, makes no difference, a negative 20x minus 3x. And what that does is it gives us 4 terms instead of 3, and now I can just factor by grouping. Okay, what do we do with grouping, right? With grouping, we just split this into two different groups. The first 2 terms was our first group, and the last 2 terms was our second group. And what do we do with those? Okay, so that line separates them. What did I do with the first group? Yeah, we want to factor out the greatest common factor of the first group. Good. So what is the greatest common factor of group 1? Well, we're going to go positive because the first term, the leading term is positive, right? So positive 5x. And then what's left behind? Actually, not x, say it again. 3x minus 4. Okay. And then what was next? What about, how did that relate to group 2? Do you remember? Good. We had to have the same binomial in group 2. I'm going to put a plus sign in the middle to join the two groups. And that's really, honestly, a good idea to do. So you just remember they're separated, right? And then whatever I had here is going to get reflected over here. This has to be a 3x minus 4. What goes out front in this case? Negative 1. Good. So we want to figure out what do I have to undistribute to make that happen. And it would just be a negative 1. And then we'll check it by distributing the negative 1. Negative 1 times 3x is negative 3x. Negative 1 times negative 4 is plus 4. So it worked, right? And then the last step was what?
3x minus 4 and put 5x minus 1.
There you go. Good. So we're going to undistribute the common blue factor from each group out to the front, right? Good job. So that goes that way. That goes out to the front. And we end up with 3x minus 4 times 5x plus negative 1. And we would just rewrite that, wouldn't we, as 3x minus 4 times 5x minus 1, right? And we're done. It's factored. Okay? Give me thumbs. Is that ringing a bell? Is that making sense? Okay, so that's the same way we're going to factor 4-term polynomials. We're going to write them in standard form. So biggest power of x starting on the left and working our way down. And of course, we'd always want to try to factor out a GCF from the whole thing before we did this. But there is no GCF for all 4 terms there, right? And we'll just do the same thing. So we're going to break this up into 2 groups. Okay, Hayden, what am I doing first for group 1? Same thing I did last time. What do I try to do for group 1? There you go, GCF. And what is my GCF for group 1 here? There you go, good. 8x cubed. And what's going to be left behind if I do that? Annika, what am I left with from this term? There you go, good, x plus 9. Okay, Mr. Lunny, what goes over here then? There you go. Okay, and I've got my plus sign in the middle. And what would have to go out in front then? 1. Okay, and we'll check it. 1 times x is x. 1 times 9 is 9. So it works. Ella, what's my last step here? Maybe my last step. Okay, help her out. Tabry, what do I do next? There you go, good. Pull the x plus 9s out front. So we get x plus 9 times, what's left behind then? Okay, good. So that was really nice. It was in unison there. So now at this point we're done with grouping. But we may not be done factoring. We always have to look at what we've got now and see, could I go any further? Could I? Anybody see a way I could go a little bit further there? Is there a factor I could split further? I got a sum of cubes there, don't I? Right? And my sum of cubes pattern, let's just remind ourselves really quick. A cubed plus b cubed factors how? A plus b times minus AB plus B squared. Okay? And for our sum of cubes here, 1 is just 1 cube, but what would the first term be? It's a cube of what? 2, yeah, good, 2x, right? So then when this thing breaks up, how is that sum of cubes going to factor? What's the first factor going to be? 2x plus 1, there's my a plus b, right? And then my trinomial? Ah, good, very good. So we're going to get a quantity 2x squared, which becomes 4 times x squared. Good. Minus 2x times 1, which is 2x, plus 1. Good. And don't forget, we've still got our x plus 9 out front. So there's our answer. Okay? Give me 1 to 5. How are we doing? Okay? Oh, we're climbing the ladder. We're getting there. Good. Okay, try that one real quick. You can go to a board, try it on paper. I don't care. Just give it a quick try. Try one on your own. I've got a bunch of new pens over there if you want to go to a board. Good job. That's it. Good. Yeah, okay, but Aubrey, on this one, you have to stop there because x squared plus 4, that'd be an a squared plus b squared, which is that's not a pattern, right?
Yeah.
You can only do the difference of squares, so you just would stop there. Yep, good. Good job. Okay, looks like we're kind of on the right track here. So what's my GCF from group 1, everybody? Okay, leaving behind. Okay, so I need an x minus 8 there. Does it work? Yeah, I could pull out a what? 4 from the second group. I've got my plus sign in the middle. So my final answer is what then? X minus 8 times x squared plus 4. Can I go any further? No, I can't, because this one, even though x squared is a square and 4 is a square, there is no sum of squares pattern. A squared plus b squared is no pattern, right? We can't do anything. Good job. Okay, just another quick couple here, and I'll get you working. How about this one? What would my GCF be from group 1? 5x squared. Okay, what's left behind? X plus 2. Okay, so then we would need to have an x plus 2 over here. Well, what times x is 2x? 2. But now let's check it. See what happens if I check it. So 2 times x is 2x, but 2 times 2 is 4, not 6. So did it work? Didn't work, right? So this one, we can just cross out all that work, and the answer is does not factor. Okay, does anybody see a quick little test or trick that we could have done by just inspecting that polynomial at the beginning? Could we have predicted whether grouping was going to work or not? Anybody see a quick little trick? I'll give you a hint. It has to do with just the coefficients. Any ideas? Okay, here it is. All you have to do, you can quickly check right away just by inspecting to see if factoring by grouping is going to work for a 4-term polynomial. If you write the polynomial in standard form, from big powers of x to small powers of x, and you look at the 4 coefficients in the 4 terms, called the first one a, second one b, third one c, fourth one d. In order for grouping to work, the ratio of a divided by b would have to be the same as c divided by d. That's it. Okay? So for example, if we wanted to look at this example right here, see if this one would work. Should we group it or not? Should we factor by grouping? Well, 8 divided by 72 would have to equal 1 divided by 9, which it does. So grouping is guaranteed to work. Guaranteed to work. Okay? If the numbers are big, sometimes it's hard to tell if the fractions are equal. You can always just cross multiply to see if you get the same cross products. 8 times 9 is 72. 72 times 1 is 72, and those are equal. So yeah, that one's going to work. How about this one? Well, 5 divided by 10 is not equal to 2 divided by 6. And we can see that with cross product really quickly and easily. We get 30 for one cross product. We get 20 for the other. And those are not equal. So don't even bother trying. That one's not going to work. Okay? Make sense? Quick and easy way to tell if you want to go through the hassle of factoring by grouping. Okay, there's the test, right? All you got to do. Check the ratio of first 2 coefficients to the ratio of the second 2 coefficients and see if they're the same. Okay, let's just maybe look at a couple just quick more. I want to make just a couple points before you jump into the assignment. What should I do first here? I got 4 terms. Do I just jump into grouping? I could, but it's going to make more work for myself if I do. What do you always want to try to do first? Factor out a greatest common factor. Yeah, is there anything we could undistribute? We could undistribute a 3 and an x squared. And remember, when we're undistributing a GCF, we're always going to keep the sign in our GCF of the leading term, right? So we're going to undistribute a negative 3 a negative 3x squared, and then what's left behind is going to be a 4-term polynomial that will factor by grouping. Maybe. We'll check and see if it's going to work. So what do I get from my first term then? Good. X cubed, right? Next one. Make sure you get the signs right. Be careful about the signs. Minus 6x squared. Good. Plus 25x minus 150. Okay, let's see if it's going to work. Is 1 divided by negative 6 that equal to 25 divided by negative 150? It is, yeah. So it's going to work, right? And then we could just factor by grouping from there, and you guys can do that. That's no big deal. The point was, you always want to factor out the GCF first because it's going to make the grouping a lot easier, okay? If we hadn't done that, we would have gotten factors. When we factored by grouping, we still would have had to undistribute stuff from each individual factor, and that's harder to catch. Just always remember, always, always, always try to factor out a GCF first step when you're factoring. Okay, one more, and I think we're good. Okay, that looks really hard. It's not at all. No big deal. I mean, it doesn't look really hard maybe, but it's got x's and y's, so it looks more confusing visually. But it's no big deal. We can still do the same thing. Look at the coefficients. 12 over negative 16, is that the same as negative 3 over 4? It is. So it's going to work. What's my GCF from group 1 here? (4x). Everybody agree? I can undistribute a 4x, leaving behind what? 3y minus 4. Okay. So we're going to make a plus sign in the middle, and we got to have, we know it's going to work. We did our test. Over here we get a 3y minus 4. And what would I have to undistribute to get that? Yeah, negative 1. Okay. So we got it. What's our answer? Let's do the blue first. Good, so 3y minus 4 times 4x minus 1 plus negative 1. Got it. Okay? Give me thumbs. How we doing? Okay, you can go to work.